Okay, let's look at multiplying radicals. So when you're multiplying radicals, first of all, what radical means is a square root. That's anything with a square root. And so you multiply radicals just like you do variables. So what I mean by variable is back previously, if we'd been multiplying 2x times 3x, we multiply number times number. 2 times 3 is 6. And then we say x times x is x squared. You do number times number, variable times variable. So the same thing's true with radicals. If you're multiplying the square root of 2 times the square root of 3, that equals a square root of 6. A radical times a radical gives you a radical. But if you have a mixed number, say you have 2 square roots of 3 times 5 square roots of 2, then you multiply number times number. 2 times 10 is 5, and then square root of 3 times square root of 2 is square root of 6. You multiply number times number, number times number, radical times radical. And then another thing I want to show you as a shortcut is when you multiply radicals that are the same, like the square root of 3 times the square root of 3. Well, a radical times a radical is a radical, so the square root of 3 times the square root of 3 is the square root of 9. And we know that the square root of 9 is a regular 3. So when you multiply two radicals that are the same, it gets rid of the square root, because what you're really doing is squaring a square root, which means that they're opposites. So anytime the numbers inside the radicals are the same, it gets rid of that square root. So like the square root of 2 times the square root of 2 is just a regular 2. Or if you have a big one, say the square root of 27 times the square root of 27 is just a regular 27. So when those square roots are the same, you're squaring a square root, which gets rid of the radical. Okay, so let's look at multiplying. So just like in algebra, when you have a number outside, you have to distribute. So we're going to take this square root of 2 and we're going to multiply it times both things. So we're going to say the square root of 2 times the square root of 32 is the square root of 64. The minus comes down. The square root of 2 times the square root of 9 is the square root of 18. So we distributed. And now this is a problem like we did in the last section where we had to simplify. We know the square root of 64 is equal to a regular 8 because that's a perfect square. Let me pull my perfect squares over here from the previous lesson. We know that the square root of 64 is equal to 8. And then we need to simplify the square root of 18. That negative comes down. The square root of 18 is not a perfect square, but remember you start where it would be in the list and you work your way backwards. 16 won't go into it, but 9 would go into it. So the square root of 18 breaks up to be the square root of 9 times the square root of 2. And we know that the square root of 9 is a regular 3 square root 2. So this becomes an 8 minus 3 square roots of 2. So that 8 would just come down. This next one is a whole number outside the parentheses, so we're going to distribute that. But remember, you can't multiply a regular number times the square root. So 7 times the square root of 50 is just 7 square roots of 50 minus, and then 7 square roots of 18. We just distribute that regular 7. And now we have to simplify these square roots like we did previously. So 50 is not a perfect square. It would fall right here. And when we work backwards, that would break up to be 25 times 2. The square root of 25 is a regular 5. It's going to multiply by that 7 and become 35 square roots of 2. 18, again, it's not a perfect square, but 9 will go into 18 2 times, so 9 times 2. The square root of 9 is a regular 3. It's going to multiply that by 7 and become a negative 21 square roots of 2. And now because the radicals are exactly the same, we can subtract and say 35 minus 21 is 14 square roots of 2. We couldn't simplify this one because this is a whole number and this is a square root. You can only simplify them when the square roots are exactly the same. And again, we did that in the last section. Okay, let's go to the next one. Now we have two terms. I don't think we're going to need this anymore. 2 terms times 2 terms. So this is where we FOIL, or you multiply all the combinations. So we're going to do the first times the first. And you don't have to show this step, but what we're doing is we're saying the square root of 7 times the square root of 7 is the square root of 49, which is a regular 7. But again, you don't have to show all that work. I'm hoping you can do that in your head, but I'm just writing it here so you can see what I'm multiplying. So first times first. And then I'm going to do first times second. The square root of 7 times the square root of 14. And you got to check your signs there. It's a positive times a positive, so it's a plus. And 7 times 14 is the square root of 98. So I didn't draw my little arrow there. Then we're going to do the inside. I'm sorry, that's a negative. Positive times negative is a negative. The inside is positive. Now the square root of 14 times the square root of 7 is a positive square root of 98. Can't write very well. And then a positive times a negative is a negative. And the square root of 14 times the square root of 14 is just a regular 14. So that's that little shortcut. The square root times the square root is just that number inside. But now a negative 98 and a positive 98, those will cancel out. And all I have left is 7 minus 14 is a negative 7. So anytime you have something that you're foiling where they're exactly the same except for one of them's positive and one of them's negative, that's always going to cause those middle terms to cancel out, because if they're opposites, it makes them cancel out. So we'll come back to this in a minute when we're looking at rationalizing the denominator. But now you see this one's not the same. They are opposite signs, but nothing's really going to cancel here when we multiply this out. We're just going to say the square root of 3. Again, you don't have to show this step. Times the square root of 5 is the square root of 15. And then we do the square root of 3 times a negative 2. We're multiplying, so that's a negative 2 square roots of 3, because we can't really multiply number times square root. Inside would be a plus 3 square roots of 5. And then last would be a negative 6. I can't simplify 15. Let me pull this back over here, because there's no perfect square that goes into 15, so we can't simplify that. We can't combine these because these aren't the same, and so this is as far as we can go on that one. Okay. This next one, same thing. I'm just kind of doing one of every type that's going to happen. So here, let's look at this. This is a square root of 7 times 2 square roots of 7. So let's write that out. Square root of 7 times 2 square roots of 7. So this is like a 1 square root of 7 times a 2 square roots of 7. So you're going to say 1 times 2 is 2. And the square root of 7 times the square root of 7 is the square root of 49, or a regular 7. And then 2 times 7 is going to be 14. So you got to multiply the square roots times the square roots and the numbers times the number. Then we're going to say the square root of 7 times 3 square roots of 11. Again, that's like a 1. So 1 times 3 is 3. The square root of 7 times the square root of 11 is the square root of 77. And a positive times a positive is a positive. Then we're going to do the inside. Again, that's a 1 square root of 11 times the 2 square roots of 7. So 1 times 2 is 2. Square root of 11 times square root of 7 is square root of 77. And a negative times a positive is a negative. And then we have last. So that's a square root of 11 times a 3 square root of 11. That's like a 1 there. So 1 times 3 is 3. Let me do it up. Oh well. 1 times 3 is 3. The square root of 11 times the square root of 11 is just a regular 11, or that comes out to be a 33. I didn't line this up very well. Let me rewrite it. So we've got, well, we can just do it here. So now we combine like terms. This is a negative times a positive is a negative. So the end came up to be a negative 33, and a positive 14 would give me a negative 19. And then these insides, remember that's a 7 right there, that if the square roots are the same, you can subtract them and say 3 minus 2 is 1 square root of 77. That's your answer. Let's look at this next one. This squared does not mean to square both of those. This squared means there's 2 of these parentheses. And so it's the square root of 11 minus 1 times the square root of 11 minus 1. And you've got to FOIL it out. So you're going to say the square root of 11 times the square root of 11 is a regular 11. Hopefully you're getting to where you can do this a little bit faster. The square root of 11 times a negative 1 is a negative 1 square root of 11. A negative 1 times the square root of 11 is a negative 1 square root of 11. And a negative 1 times a negative 1 is a positive 1. So we combine our like terms. 11 plus 1 is 12. And then a negative square root of 11 and a negative 1 square root of 11 is a negative 2 square roots of 11. And that's your answer. If you put the square root first and then the number, that would be perfectly okay. Okay, this last one, or it's not the last one, but the last multiplying one, is just be careful. This is like a 4 times a 1. So this is a 4 square root of p times a 1 square root of p. So 4 times 1 is 4. And the square root of p times the square root of p is a regular p. Then you've got 4 square root of p times 9. So you're just going to do number times number. 4 times 9 is 36 square root p. And that's a negative there because a positive times a negative. Then we have the inside. But now do you see we have a square root 7 times a 1 square root p. So we're going to, this is like a 1, so 1 times 1 is 1, and the square root of 7 times the square root of p is the square root of 7p. And can't simplify anything there. And that's a positive. And then the last, positive times negative is a negative, and it's the square root of 7 times a regular 9 is just a 9 square root of 7. Now we always put the number in front, because if I wrote square root 7, 9, it might look like that 9 was under the square root. So you always want to put the number in front and then the square root. Just like we write 2x, we don't write x2 because it looks like times 2. So always put the number in front. Nothing's the same, so we can't combine anything. So that's just our answer. So that's multiplying. Now let's look at dividing. And so when we're dividing, we call it rationalizing the denominator. And so just like we've had rules that say you can't leave a negative exponent, in order for something to be in simplest form, you cannot have a square root in the denominator. And I just noticed this one should be a square root of 7 on the bottom. So this 11 over the square root of 11, we can't leave this as having a square root on the bottom, or it wouldn't be in simplest form. And so remember when we looked at little shortcuts, when you multiply the square root times the square root of the same number, it gets rid of that square root. So we're going to use that process to get rid of this square root of 11 on the bottom. Because if we want to turn that into a regular number, all we have to do is multiply it by the square root of 11. And we can do that on the bottom as long as we do it on the top. Because the square root of 11 divided by the square root of 11 is just a 1. And you can multiply anything by 1 without changing the value. So this is called rationalizing the denominator. You're multiplying the top and the bottom by some square root. That'll get rid of the square root on the bottom. So on the top, we have a regular 11 times the square root of 11. And on the bottom, the square root of 11 times the square root of 11 is the square root of 121, which is a regular 11. That's always going to get rid of the square root because you use that number on purpose to do that. And then my 11s will cancel out, leaving me the square root of 11. And that's your final answer. If you put this in the calculator and this in the calculator, they're equivalent. They're the exact same value, but this is considered in standard form. So the same thing with this one. We're rationalizing the denominator. I want to get rid of this square root of 7, so I'm going to multiply the top and the bottom by the square root of 7. So 3 square roots of 2 times the square root of 7 is 3 square roots of 14, because you just multiply the square roots. And then on the bottom, the square root of 7 times square root of 7 is a regular 7. Now you want to check if you can simplify 14. Let's go back to our perfect squares. But there's nothing that will go into 14 evenly, so that's just your answer. Okay. The square root of 10 over the square root of 3. I didn't write that real good. That square root goes over the whole thing. So this is really the square root of 10 over the square root of 3. So to rationalize the denominator, we're going to multiply by the square root of 3 on the bottom and the top. The square root of 10 times the square root of 3 is the square root of 30. And the square root of 3 times the square root of 3 is a regular 3. Now, you cannot divide that and say that's the square root of 10. You can only divide square root by square root, number by number, just like multiplying. So that's really in simplest form. The only thing you can do is see if there's anything that would simplify 30. But when you look, 30 would fall here, 25, 16, 9, 4. None of those are going to 30. So that's just your answer. Okay, now let's look at this one. Now we have more than one term. So with a single term, you just multiply the top and the bottom by that square root. But on this one, I need to get rid of the square root of 3. But I've got this 5 plus the square root of 3. So I want to go back to this problem we did before. Well, remember when these were exactly the same, but these were opposites, do you see it got rid of those square roots and left us this whole number? So we're going to do the same thing on this one. We're going to do the opposite. So since this is 5 plus the square root of 3, think that about being in parentheses, I want to multiply that by 5 minus the square root of 3. Whatever that sign is, you do the opposite, and then I have to do the same thing to the top. So I'm multiplying by 5 minus the square root of 3. So on the top here, you're just distributing and saying 4 times 5 is 20, minus 4 times the square root of 3 is 4 square roots of 3. And then on the bottom, you're foiling. So you're saying 5 times 5 is 25. 5 times a negative square root of 3 is negative 5 square root of 3. Inside, the square root of 3 times a regular 5 is a positive 5 square root of 3. And in the end, a square root of 3 times a square root of 3 is just a regular 3. These will always be opposites because you picked them to make it that way. So all I have to do is say 25 minus 3 is 22 on the bottom, and I have 20 minus 4 square roots of 3 on the top. Now, you want to make sure it's in simplest form, and so this is not a mathematical term, but I always call this my little triangle, magic triangle. Whoops, my pen's out of ink. And so you can simplify a radical if it'll go into all 3 of these numbers. So do you see how 2 will go into 20, 4, and 22? So you can divide every one of those by 2 and make this a 10 minus 2 square roots of 3 over 11. And that's in simplest form. So you can only divide if it would go into everything in the triangle. Say I had, I don't know, 10 minus 2 square roots of 3 over 5. Here, 5 will go into 10, but it won't go into 2. So looking at that triangle, there's nothing I can simplify on that one. So that one couldn't go any farther. In order to simplify, it has to go into all 3 of those things. Okay, and then this last one I had to cut it off because I wrote it incorrectly, but we're going to multiply the square root of 27 divided by 3 minus the square root of 3. So we're going to multiply by an opposite, just like we did above. So we're going to multiply that by 3 plus the square root of 3 on the bottom and the top. 3 plus the square root of 3. So on the top, we're going to do a distribute. So 3 times the square root of 27 is 3 square roots of 27. And then square root of 27 times the square root of 3 is plus the square root of 81. And so let's go ahead and keep simplifying like that. So when we have the square root of 3 square roots of 27 plus square root of 81, the square root of 27 breaks up to be 9 times 3. The square root of 9 is a regular 3, so it's going to multiply by that 3 and become a 9 square root of 3. And then the square root of 81 is just a regular 9. So that becomes the 9 square root of 3 plus 9 on the top. And then on the bottom, 3 times 3 is a regular 9. 3 times a positive square root of 3 is plus 3 square roots of 3. Inside is a negative 3 square roots of 3. And then a square root of 3 times a square root of 3 is a regular 3, and it's going to be a minus. So these middle terms cancel out, and 9 minus 3 is a 6 on the bottom. But now we want to look at that triangle, but do you see it's not really in order? This should really be written 9 plus 9 square roots of 3. You always write your whole number first and then your square root with my 6 on the bottom. So when you look at the triangle there, everything can be divided by 3. So this becomes a 3 plus 3 square roots of 3 over 2. And so that's rationalizing the denominator.